Hey everyone, we're moving on to a new chapter in the C# class. And this chapter is, again, I'm a broken record at times, fundamental to learning C#. I'm a broken record because I feel like every chapter that I've talked about so far has been just a real foundational type chapter and material, and methods are no different. I always like to start a lecture on the importance of a topic, and I can really summarize this pretty well. In that methods, there's an acronym here. Why should we learn to code methods? There's an acronym that really kind of help understand why we would code methods. DRY stands for don't repeat yourself. And so that's right here the beginning of a really important topic, which is not repeating the same code over and over and over. The idea of reusing code or code reuse. There are a lot of different things in coding that help us keep our code dry, again, so not having repetitive code. Methods are the first tool that we learn to help us do that. Why is this an important topic? Why is code reuse important? And it comes down to being efficient, right? So writing efficient code. It comes down to when it's time to troubleshoot. If we write, instead of writing our code, maybe let's just say 3 times repetitively, well, if that algorithm that we wrote, if those lines of code have a bug, then you have to fix that bug 3 different times. If you wrote it 3 times, you found a bug once, then you have to fix it in 3 different parts of your code. And so learning to code efficiently means, okay, instead of writing that code 3 different times, let's write that code 1 time and then reuse it multiple times. So you're just learning to code more efficiently. When it comes time to troubleshoot, then you just have to troubleshoot that 1 block of code versus troubleshooting it in 3 different places. And so when it comes to methods, that's the benefit. These are the benefits of using methods. But even so, why use methods? And I would answer that with keep your code dry. Kind of increase the font here. Keep your code dry, efficient, clean, if you want to say clean. That's why we use methods. But what are methods? It's always important to understand why. Again, it helps us write clean code, non-repetitive code, and code that solves our tasks in efficient manners. In an efficient manner. What are methods, though? Methods are reusable blocks of code. And so a block of code, as we've already defined, a block of code is anything with an opening curly, is anything between the opening and closing curly braces. So we've had blocks of code like in an if statement, a do while. These are all blocks of code. So we're going to write a block of code that is now reusable. So methods are reusable blocks of code that helps us keep our code dry. A block of code is simply anything between curly braces. All right. So we're going to learn to code methods. We understand why we're coding methods. And that's where we're going to start. Now, the objective here, again, I'm not going to follow this all too closely. The PowerPoint, I'm not obviously reading off the PowerPoint, is describe the signature of a method. And I think I want to do this by coding. Surprise, you're not surprised. I'm going to create a GUI. All right. Oops. We had a lab. Let me see. These are our next chapter labs. I want to glance at these real quick. Okay. You're going to notice some repeat labs in here. The repeat labs you've already solved, but now we're going to solve them with methods to make them more efficient. Is there, again, the reason why. We had a lab that was like a rock, paper, scissors, and kind of, I'm going to use that lab in my demo here. If I build this out. Okay, so we've got 3 button clicks. By the way, these are methods. These things that are created right here, they have a more specific name, which are event handlers. Okay, let me zoom in. Event handlers are methods that respond to user interactions, aka user events. So an event handler are simply methods that run when the user clicks the thing or hovers the thing or whatever action kind of initiates or fires this event handler. Okay, so event handlers are methods. But we're going to be writing our own methods. And so when it comes to writing your own methods, a method has something called a signature. right? You guys have your signature for your for your name. A method has a signature for its creation. And so, the first step in working with methods, the first step is to declare the method by coding its signature. Okay, now what you'll notice here is I'm still inside of my class. You'll notice my class ends on line 38. But I'm not inside of an event handler. These are my event handlers. So I'm going to declare my method inside of the class, but outside of the event handlers. By the way, this is something we haven't talked about. This is called a constructor. It's also a method. Okay, we're not inside of the constructor. It is a method. We're not inside these curly braces. We're not inside of these curly braces, but we are inside of the class. Okay, now I could declare my methods at the bottom of a class. You can declare a method at the bottom, at the top, or in between your event handlers. Okay, if you really wanted to, you could come into right here, like on line 30, and put a method here. Method could be declared here. Okay, most of the time, companies have conventions as far as where they want their methods to go. Most companies will say, okay, we're going to put all of our methods at the bottom, we're going to put them all at the top, or wherever they're going to put them. Point being, the company you go to work for will tell you more than likely where they want your methods to exist. For the sake of this demonstration, I'm just going to put my methods at the bottom of my source code underneath all of my event handlers. The first keyword in a method signature is either public or private. Now, there are other keywords. There are other keywords besides public or private, but we're going to keep it simple for right now. The difference being this: private means that only this file, this form1.cs, can work with our methods. So if I declare a method private, a private method means only this file can work with the method. And you might guess public method means other files can work with the method. Right now everything's in one file, okay? So we have not worked with multiple files yet, really, as far as the code that we write. I guess, when you look in here, there are a lot of files, but for the most part, all of our code is being accessed right within here, form1.cs. So we're going to mark our method as private. Now, by the way, the first keyword in method signature is either public or private. This keyword, either public or private, is called the access modifier. Okay, so we're learning methods. The first step of learning methods is learning how to create a method. The first step is to declare the method by coding its signature. Okay, after you create, the first step is to create the method. After you create it, the second step, I'll kind of get ahead of myself here, but the second step is to call So you declare the method or you create it, but just creating a method doesn't actually use it. You then have to use the method by what they say calling the method. So declare the method, call the method, 2 steps. When you're declaring it, the first thing is the access modifier. Access modifier for right now, public or private. We will learn other access modifiers as we go along, because there are definitely more. The next keyword after public or private is a data type. Okay, now I'm gonna expand on this just a little bit, but what data types do you know? So this is my first question to my class this morning. What are the data types that you're aware of? And you can type it out in Discord for me. Let's go ahead and list some data types for me. Not all at once. Okay, the first one is double. Yeah. So you guys obviously are aware what data types are. It could be a double. It could be a string. It could be an int. It could be a byte. It could be a char. Okay. Now, that's what this next keyword is. It is a data type. But more specifically, it's what's called the return data type. Okay? And this return means something. But we'll just say string. So we're going to be returning something. And I have to explain what that return means. Let me explain that real quick. This is one method that's an event handler. These are our event handlers. So our code will be executing in here. And at some point, once we call this method, this method is going to be down here. We need to be able to send data back and forth. Send data from the event handler to the method. And we also have to be able to receive data from the method. So if you think about these as 2 different parts, we got the event handler, and this event handler needs to take a piece of information like the number 5 and send that piece of information into the method. So it's just sending information back and forth, right? So you're sending information from the event handler into the method, and then the method can send information back to the event handler. Well, this return data type says that the information that we're going to send back to the event handler is a string. So this is a data type of information that this method is going to be sending back to the event handler. Okay, so at a high level, this is really what takes a lot of practice or a lot of getting used to. You're sending information back and forth. So these event handlers send information and they receive information from the information, from the method. Okay, this data type is a data type. Data types, but is the type of information that this method will be sending back to the event handler that called it. Okay, this would be the event handler that called this method that we're about to create. All right, so first is the access modifier. Access modifier is first. Then we have the return data type. Next, we have our method identifier. Well, we've had identifiers for our variables. We've had identifiers for our variables, and we might have had a variable here called string first name equals Bob. Okay, well, this is an identifier called first name. Anything that the programmer gets to identify or name, that's an identifier. Okay, variables are identifiers. The names of our methods are our identifier. Do something. That's the name of my method. Next, we have our method identifier followed by parentheses. Oh, parentheses. Good luck spelling that. I think I got it right. Did I get it right? Probably not. No. SES. Parens the SES. SES. All right. Step 1, access modifier. Step 2, return data type. Return means this method will send information back to the method that called it. This is a method that's an event handler that's going to call our method. This method is called something. Now, if you hold your mouse over there, it says it doesn't return anything. This keyword right here says that this method needs to return a string. And right now, it's not returning a string. If I use the keyword return, and I put the words hello world inside of quotes, that's a string literal. And now we have an access modifier. We have a return data type. We have an identifier followed by some parentheses. We've got the keyword return, and it says hello world. Now let's call this method. This is a method, a bare bones method. This method returns a string that says hello world. Put a little label in here. Call this label result. All right. So now we have completed the first step. We've declared our method signature. What is the method signature? Specifically, it is the access modifier, the identifier, as well as if there's anything in these parentheses. The return data type is not part of the method signature. Okay, believe it or not, it's simply the access modifier followed by the identifier, and what's in, if there's something inside of the parentheses, what goes inside the parens are called parameters. Parameters are optional, and I'll explain them. But to say a method signature consists of access modifier plus identifier plus params, your parameters. Params, parameters, same difference. Params, parameters. We have now created our method signature. Inside of the method, this is known as our method body. This is what the method does. So we've essentially identified our method by giving it a signature. We have a very simple method body. This method body simply sends information back to the method that calls it. So since this returns a string, if I say label result.text equals do something. Now keep in mind, do something returns a string. So we have a string on the left equal to, this is our method call. So second step is to call a method. This is calling the method right here. And if I even say plus equals, well then it will append, like so. For example, if I run this, if I click scissors, it just says hello world, right? But I can click it 100 times and it's just overriding that label to show you that it is in fact returning hello world every time I click it. I can do that, which doesn't, it shows you that that method is being run repetitively. So the task of outputting some sort of string to the console is being repeated. Okay, so we didn't have to write that 100 times. We just wrote that once, and we're getting a repeated function or repeated output. All right, quick review. What is this keyword? Private or public, those are known as what? Those are known as access modifiers, correct. What is do something? Do something is known as our method what? Do something is our method identifier. What notation do we use for our methods? Is it camel notation or Pascal notation? Yes, sir, Pascal notation, right? Because we're starting our methods with capital letters, okay? So if it starts with a capital and it's got parentheses, you know that's a method. That's our convention for this class. Not all companies, not all languages use Pascal notations for their methods. That's just our convention. Okay? What is string? What is that keyword? It is a return data type. That is correct. What if I change string to int? Why isn't that working? Well, it's not working because, it's not compiling because it says it cannot convert string to an int. So what if I do this? Return 5. Now every time we're returning the number 5. We come up here. And let's see. Interestingly enough, it's able to convert that 5 into a string. So we got an implicit cast going on because the number 5 is being cast into a string. So we got a string on the left and a string on the right. Yes. So we've got our identifier, we've got our access modifier, we have our return data type. If there's something inside the parentheses, what are those things called? And it's right on the screen. Parameters. What if our method... All right, good. So that's our review. Here's a little bit of new information. So we're sending information back and forth. When I send it back and forth, we're sending data to from the event handler to the method. and we need to be able to receive data from the method. So for example, do something, this event handler receives information from our method. So we kind of have done this already. We've already received something, right? And then what we did was we took that information that we received and we put it into a label. But we also can optionally send information. So when we receive data from a method, we got two options. You can receive 0 or 1 piece of information. So let's think about this. We can receive 0 or 1 piece of information. Right now we're receiving 1 piece of information. That's done with the keyword return. So we demonstrated returning a string. We can return an int. Like we could do int age equal to 5 and then return age. And this also returns an int. Right? So we've demonstrated how to return information back if you have a single piece of information. Now, maybe I should better word this. Receive 0 or 1 variable. Because I need to expand on that. Receive 0 or 1 variable. This is a variable that we're sending back and forth, or a single piece of information. Now, the question then becomes, well, what if the method just needs to run and it doesn't need to send information back? Okay, and so the way that you do that, because you can receive 0 pieces of information. We demonstrated 1, but how about 0? Well, in that case, you take the return data type and you mark it as void. In this case, since we now take our return, we took our return data type and marked it as void, we no longer have to return anything. In this case, what we were doing is before, if I take it here, the output is being done in the event handler, which is fine. This is actually slightly preferable. But now we marked our method as void. And so now let's do the output. The output can be done in the method instead. Label result.text plus equals 5. Now we're not returning any piece of information. We're simply doing the output right in the method. Whoop, of course. Now we don't need to assign the method call into a text. We can simply call the method. So the output was being done in the event handler. Now now we're just calling the method, and the output is done here. So this always confuses new students. It's like, wait a minute. Should the output be in the method? Or should the output be in the event handler? Generally speaking, so the answer to this is not always always one answer, but there is a best practice. Okay? The best practice is this. Methods should perform a single and simple task. And so maybe, for example, just as a demo, your method does some math. The more complex your method, okay, if your method does too many tasks, you should consider breaking that method into smaller pieces. Because when methods grow in size and grow in complexity, they become harder to work with, harder to troubleshoot, harder to fix. And so the rule of thumb is that your methods should perform a single and simple task. So if your method does some math, then your method should not also do the output. Okay, so this is kind of an architecture type of question, like a program design type question of where should these functions go. Again, rules of thumb. A method should perform a simple and single task. Therefore, if your method already does a task like some sort of math or some sort of equation, then you should return that information back to the event handler to do the output. Okay? So generally speaking, that's the rule of thumb, but kind of lost my train of thought there. Okay, so we know, kind of stepping back, to receive information, you can receive 0 or 1 variable. The reason I kind of changed my language on that, what about an int array? Yeah, in fact, you could do that. So if I had an array of ints called numbers equals 3, 4, and 5, I could return numbers. What? And obviously there's more than one piece of information in this array of numbers. Again, this is still our return data type, except for our return data type is an array. Now, do something returns an array of ints. So if I could say int nums equals oh, bad habit. There we go. So now what I've done when I call do something, now that do something returns a value, it's returning an array of ints. So I'm going to store it in an array of ints. Then I'm going to loop through that array and output it into a label. You see 3, 4, 5 gets outputted into the label. So the return data type has to match. I've got a return data type on the right of an array of ints, and so I have to put it into an array of ints on the left. I've got an array of ints on the left and an array of ints on the right. Now a question here becomes this. Notice my identifiers inside of the event handler, I called it nums. Inside of the method, I called it numbers. Could I, in fact, call it numbers in both places? Yes, I could. I could rename this. And then what we have here is we have two local variables. This numbers is local to the event handler. So this numbers scope is inside of this method. And this numbers scope is inside of this method. I think it helps people to give them the same identifier. I think maybe it would confuse people. I think it helps to name them the same thing. Yeah, I'm gonna go over that, Evan. I'm gonna talk about those naming differences for sure. Okay. Got a question coming, so I'm waiting for that question to come through. So if you change the access modifiers, can you reuse it? So the only thing that we have is... Okay, good question. So do something is a method that every time I click this button, I'm reusing the method. So the access modifier right now, whether this is private or public, right now it does not make a difference because every time I click this button, I'm reusing this method. Okay, and I'm gonna show you solving this rock, paper, scissors. I'm going to show you kind of a more another case where we're reusing this method on multiple event handlers. So, you know, for example, and I'll get into that a little bit more. I could do something like this. So now I've got 3 button clicks, and on each button click, I'm reusing this do something method. So I've written this method once, but no matter what button I click, I can call do something. So that's really some of the code reuse. Correct. Yeah. Because the difference is that if I had another file and I tried on this other file to use this method, that other file would not be able to access it because it's marked as private. Whereas if I made this public, if I had this other file, then it would be accessible to the other file. So it's kind of hard to understand because we haven't worked with multiple files yet. But that's the difference for right now. Just imagine there's another file, and this public or private only makes a difference in that other file that we haven't created or used yet. So we know that this is our return data type, which is good. We know that it can return a single piece of information or an array, which is also good. We also know that it can return void. Void means it does not return anything. Up here I said that you can receive 0 or 1 variable. Let's show void. If there's void, it doesn't do anything. And here we can't assign it equal to anything since it's just going to run. This method just runs at this point. Okay, but going back to what I was saying earlier, methods, this is our method, they can receive 0 or 1 variable. The way that's done is with the return data type and the keyword of return. I've demonstrated how to do both of those. What I have not done is shown how to send data from the event handler to the method. Again, why would you do this? It's all of a question of architecture. Like, where do you need to do the different pieces of the program? Okay. But safe to say, there's really two things. You send information to the method, and the method can send information back. So really that's what you getting comfortable with is going to be the most important piece this week, is getting comfortable sending information to a method and sending information back. We know information sent back can be 0 or 1 piece. 0 or 1. Sending data to a method can be 0 or many pieces. Each piece of data is called a parameter. And so inside of our do something, remember we said inside the parentheses are called parameter. Parameters are just variables. And you could think of them as local variables. They're local to this method. And so I'm going to set this method up to receive a piece of information. No, I'll do some string name. Label result.text equals, and then I'll use name. So this method receives a string and then outputs that string to the label. So that's the one thing that this method does, is output. Now you'll notice do something is not compiling. It says there's no data, there's no argument. When you think of argument, think there's no data given that corresponds to the parameter name. So now that this method has a parameter, we have to provide a name. I'll put my name in there. Remember I temporarily put that in those. So now do something Evan. It might seem like on the surface what we're doing is the same stuff as before, just making it more complex. And on some level that's right. We're making our code more complex for the benefit of code reusability. And I'm getting to a point where I can actually demonstrate this in a useful way. We're almost there. Now, I did say that there can be 0 or many pieces of information. Separated by commas, now we have 2 parameters. So now when I call do something, I have to pass it a string, comma, and an age. So now our method receives two pieces of information, and it does not send back any, and it just outputs that information to the screen. Now here's a little bit of code reuse. Do something. Bob is 30. Do something. Chris is 11. So each time we append that information, and we'll throw in a little new line. So we called that method 3 times, passing it different information each time, right? I'm gonna clear out my label because that's just not supposed to be there. That little piece of text, go away. So I wrote the method 1 time, I called it 3 times. Each time I called it, I passed it different strings and different ints. So you see a little bit of code reuse there. If I click it again, it calls the method 3 more times each time I click the button. So, these are method fundamentals, all for the purpose of code reuse. I think I'm going to be able to really tie it together in a big example here at the end when I actually code this rock, paper, scissors. You'll really see the benefit of code reuse with methods when I do this actual example. A method receives information. That's when you receive, that's 0 or 1 piece. When you send information, you can send 0 or many. So if my method, as I did at the beginning, my method had no parameters, then you're sending 0 pieces of information. Okay. Could I also send an array? Yes, I could. I could have an array of doubles. Double prices. Now I have 3 parameters. I have a string, I have an int, and I have an array of double. And this would be I'm trying to forgetting my shorthand notation for this. There we go. So this is an array of doubles that I just sent across. So I'm sending a string, an int, and an array of information into a string, int, and array. These data types have to match. The order has to match. So notice I got a string first. It's got to be a string first, then an int, then an array of double, then an array of double. The order and the data types have to match for now. Okay, we'll kind of expand that later on. All right. This recording's been going for just short of an hour, so it's a good time to kind of take a breather. I'm going to go ahead and pause. All right. In terms of slides, we really don't get through much. There's just a whole lot of new information, and that's why I broke this chapter into 2 parts. We kind of talked about these different, when you're declaring a method, you got the access modifier, the return data type, the identifier, parameter list, and the body of the method. That's all review. So for example here, we've got a private access modifier, decimal return data type, get discount % is our identifier, and we've got 1 parameter. The parameter's data type is decimal. It's just a variable called subtotal. And what I wanted to point out here is that, inside of your methods, all of the loops that we learned about, our if statements, our switches, all of these can go inside of your methods. Okay, or they could go inside of the event handler. All right, there's no right or wrong answer. They might go in both. Point being, it's worth noting, if you're new to learning this, you could put your if statements and your loops inside of your methods, or you could put them in the event handlers. If you think of an event handler, it's just a method anyways. So, again, it's more of a question of design. And what I need to do is get you comfortable just working with methods, passing information back and forth. The way that we pass information back and forth is with the return data type and with the parameters, right? To send information into a method, you send it in with parameters, and to send it out is sent out with the return data type. Okay, this one has 3 parameters and 1 return data type of a decimal. Okay, the syntax for calling a method, you can put the optional keyword this in front of the name of the method. I didn't do that. Like in my demonstration, which I've kind of cleared out, in my demonstration, I just called the method. It was called do something, and I just put do something like that. And if it returned a value, I put that into like a label or inside of an int. So, real quick, private int do something, return 5. So if your method returns something, then you need to store that. Int value equals do something. This is my method call. This is my method declaration. So declare method. Again, declaring my method and calling my method. If your method returns something, then you should store that value inside of a variable or in a label or somewhere. You should do something with that return data. I could put it in a label. Label result.text equals. It says cannot convert int to string, so we say do something dot to string. Click the button and output the 5. So you need to do something with it, or you need to use that data, I should say. Do something is the name of the method. Okay. So in terms of slides, we're not really going to get that far. Maybe a third of the way. Probably we're going to stop right here on slide 9. When they start talking about these optional parameters, we'll pick up with that on our next lecture after this week. So I covered all the basics, but what I want to do next on this video is a demonstration, which hopefully helps tie it all together. And that's actually completing this rock, paper, scissors game. Which I need to open the lab because I think there was a... I kind of forget what all the information was. Let me open up that lab. You guys remember what chapter that was in? Rock, paper, scissors?
I'm gonna guess chapter 4.
Okay, so this is the output. We got to have what the computer picked, player score, computer score, and player wins. And so you've got like a round score that's indicated by the player score and the computer score, and then like an overall after 3. So that's the game. So computer picked. So I'll throw a label on here, and this will be label PC pick. Player score. Name, text, player score, computer score, and we'll have a label for, I think I got a label result. Maybe I deleted that. Must have deleted my label result. So I'll add another label called label winner. So if you remember in rock, paper, scissors, the first thing that you did was you generated a random number. And so if you find yourself writing one line of code that's repetitive, you could extract that into a method. Let's do that. So rando equals new random. Rando dot int num equals rando dot next, and we said between 1 and 3, 1 comma 4, so that's 1 less than 4, 1 comma 4. And what you found yourself doing was every time you clicked one of these buttons, there you've got some repetitive code. Okay, so this is an example where you could extract this into a method. Let's see, highlight, right click. There is a there's a way to in Visual Studio to kind of there we go, extract method. All right, now so Visual Studio has this little thing where it'll help you write a method. You can kind of see the name of the new method. Okay. Point being, you can use Visual Studio to do this kind of thing. But as we're learning it, I'm going to undo that, Control Z. I'm not going to use Visual Studio to do that because it doesn't really help as much as doing it on your own. So instead of repeating this, I'm not going to repeat this. I'm going to cut the code out. I'll make it a private. It's going to return the random number. And saying, oh, okay, I'm not really saving that much, but I'm just giving you, I'm just a brief exposure. I'm going to continue to show you how you can use methods. So this method is private. It returns an int. It does not take in any parameters. So it's called generate random numbers. It uses the random object and returns a random number 1 through 3. Just to demonstrate that, if I just say label pcpick.text equals generate random number dot to string to get it to a string. We got a string on the right, string on the left. Make sure it generates a 1, a 2, and a 3, which it does. And now we can just simply call that one line of code, and it doesn't matter which one we click. All three of these generate random numbers 1, 2, or 3. Okay, so now instead of just putting that random number into a text, we'll say int pcpick we don't need a toString then. Okay, so this method's pretty simple. Generates a random number, returns that random number. You can then store that in a variable called computer pick. The next thing that you would do, more than likely, is we've got rock here. You would say PC pick of 1 equals rock, PC pick of 2 equals paper, PC pick of 3 equals scissors. And you would begin to say, okay, if PC pick is 1, else if PC pick is 2, else you know it's 3, and you would find yourself putting this if else again repetitively in each one of these. And so you find yourself with some repeat code, and you should always ask yourself at that point, could I or should I put it into a method? And the answer is here is it's a good idea, again, so that we're not repeating ourselves. So let's take this if else into a method. Now, this method actually is going to need some information. We're going to need a private maybe I'm going to return, I got to think about the return type. For now, I don't know what the return type is going to be. I'm going to mark it as void. I'm going to say determine winner. What I could do is I could say, okay, return a 1 if the player wins, return a 2, or maybe a 0 if the player wins. So I'm just thinking out loud here. Return a 0 if player wins, return 1 if PC wins, return 2 if tie. I'm thinking I'm going to do that. I could definitely do that. There might be a better way. I'll think of it as I go. To determine the winner, you need two choices. you need a PC pick and you need a user pick. So when I call this determine winner method, I'm going to take in the user pick and the PC pick. Again, 1 is rock, 2 is paper, 3 is scissors. So if PC pick is 1, so we know that the computer is rock. If the computer picked rock, then if the user pick is 1, so if the PC picks 1 and if the user picks 1, winner is a tie. We said 2, which represents a tie. Else if user pick is 2, so PC picked rock, user picked paper, user wins. We said user wins is return of 0. Else winner is 1. Well, because 1 would be the PC picked rock, the user picked 3, which would be scissors, and therefore the computer wins. And you could probably see where this is going. Else if PC pick is 2, we can even kind of copy and paste this. If the PC chose paper and the user picked rock, the winner is the computer. So PC picked rock, user picked, no, sorry. This one's PC is paper. This one, PC is rock. So you chose paper, user picked rock, computer wins. And computer wins is 1. Return 1 if the computer wins. So we got that. Winner is 1. Else, that means a tie. 2 and 2 is a tie. For a tie, we said we are returning a 2. And then that leaves the 0 for the player wins. So PC picked paper, user picked scissors, winner is player. All right. So this is the if for the rock, paper, else, of course this is PC is scissors. Scissors, user picked rock, so user wins. User wins is a 0. This would be a PC is scissors, user is paper. So this would be PC wins. PC wins is 1. And that must be the 2. 2 representing It's a tie. So PC scissors, player scissors. Okay. So this if, else. You used to put one of these inside of each. You coded this big structure multiple times. You coded that structure multiple times, one inside of each button click. Now, we don't have to do that. Now we could say int result equals, we're gonna call determine winner, passing an int for the PC pick. Obviously the user clicked rock, so we're gonna pass 1 for rock. Oh, the PC pick is in my random number. So PC pick, comma, user pick. I actually changed that because that's what I asked for first. I asked for the PC pick first and then the user pick. And what I do here is I need to change this void to an int. I'm now returning an int. And ultimately, at the end of all this, I need to return the winner. So our return data type is an int. That's our winner. You go through here to determine the winner in these different scenarios. This would be PC pick, and then the user would pick paper. And this would be scissors. So we coded this big if else structure one time, and now we're just reusing it across our different event handlers. If result, what did we say? If result is 0, player wins. Else if result is 1, we said PC wins. Else, we know it's a tie. You see the code, we're repeating ourselves here. So could I extract that out into a method? Yes. We can. Let me just demonstrate, let me demonstrate this without putting this into a method first. We'll get this working before I put it into a method. If the result is 0, the player wins. Okay, so let's make an int. Num rounds is 0. Int num player wins is 0. Int num PC wins is 0. So we'll increase the number of rounds. This will increase num player wins. PC wins. Else tie doesn't make a difference. We'll just output a tie. Gotta think about my label here. Player score. I gotta add another label. All right. Label player score dot text equals, mouse is in my way, num player wins player label PC score dot text actually on each case I'm going to output each. Label PC score dot text equals num PC wins toString I need some label for a tie, so this is, oh, that's that label right there. Which one was that? That was called label PC pick. Getting my labels crossed. That's a bad label name. This is label, oh yeah, it is PC pick. You gotta output that. We could do the output right here. Label PC pick. PC picks scissors. So we're doing a little bit of output inside of our if, else if statements. Okay. Just run this real quick and see where it's at right now. I just coded a whole lot. I don't normally like to code so much at once. Rock. You could see that neither score went to 1. So probably what I need to add in here is a, you know, like it's a tie. The round is a tie. Okay, what I'm not doing is increasing my label. Let me debug this real quick. So Let's start at the top, generate a random number, pass that pick and a number there, increase the number of rounds. Here the result should store a 0, 1, or a 2, which should be used to update my labels. So I'm kind of curious why my labels aren't being updated with their number of wins. So if I started debugging right here, click on rock, you can see result is 0. It is outputting the number of wins, and it's outputting, so that's 1, so it should output 1. Oh, there it is. Winner is 1. One to 1. This is working. 1 to 1. Am I going crazy? I thought that just wasn't working a second ago. Let me stop. Okay. We're getting results for both. I think what was confusing me was the tie. Also, what I don't have is this result in each method. That's what it was. I don't have that inside of my button paper and my button scissors click. So again, I've got this little chunk of code, and what I would have to do is copy and paste that into... I fear what I'm doing is making this a little bit more complicated than it needs to be. You probably don't need as many methods, but I'm just using these as my demonstrations. If I click on quick actions and refactoring, so I have that little chunk of code, and I want to extract into a method. And this method is going to be called output or update labels, I'll say. Update labels. So now I can call update labels. Now you'll notice where it put it. It put my update labels kind of in the middle. I just cut. And I'm going to paste update labels beneath my other method. So here's my first method, here's my second method, here's my third method called update labels, passing it a result. The result comes from the previous method. So update labels with result, update labels with result, update labels with result. Now what's really nice is I need to accommodate for my tie, and I can accommodate for my tie in one place. I just need a label for tie. So I'll just make a little label right here. Call it label tie. Its text is empty. And then what I'll do is every time I call update labels, I'll set label tie equal to empty. And then only when it's a tie will I make it say label tie. It was a tie. Label tie dot text. So there's 3 scenarios where it's a tie. Label tie dot text. Oh, yeah, that's good. So now it at least says it's a tie, and update labels is called on all 3 button clicks. So update labels here, update labels here, update labels here. We can update the rounds first. Update rounds plus plus. So generate a random number, determine the winner, update the labels. Let's test it out. You picked rock, computer picked paper, computer won 1. You chose paper. Okay, there's a bug. PC picked paper. It was a tie. No, that's not a bug. I chose paper. PC picked paper. It was a tie. I chose scissors. PC picked paper. Player score 1. I chose scissors. PC picked paper. Player score. Computer picked rock. Computer score. Okay, so now we're getting outputs on all that. Last requirement. I know this is droning on. Hopefully you're getting used to sending information back and forth with methods. Last thing. If number of rounds is 3, okay. This determine winner, I'm going to rename that to determine round winner. Better name, determine round winner. Because then we're going to have a determine match winner. We have a number of player wins and we have a number of PC wins. And those are increased. Those are basically unused variables that I need to use. Number of player wins, number of PC wins. So the winner of 2 is a tie. Player wins is 0. Num player wins plus plus for the 0. Player wins is 0 for that one, for that one, for that one. 1 if the PC wins. Num PC wins plus plus for 1. Okay, so now we have these variables we declared at the beginning to be 0. We increase them every time we determine the round winner. We increase them by 1. So that later on, we could say if num PC wins is greater than num player wins, label winner dot text after 3 rounds the PC wins, else if num player wins is greater than num PC wins, after 3 rounds the player wins, else it's a tie, after 3 rounds it's a tie. Okay, now this is only on my button rock click. So 1, oh, there's a bug. I'm increasing my score too many times. I didn't realize I was doing that. Let me go back into here. Let's determine round winner. So I'm increasing the number of player wins here. I must have been doing that already somewhere else and I forgot about it. Probably in update labels. Let me look at update labels. Oh, there it is. I was already doing that. Okay. Again, so where's the proper place to do it? There's no right answer to that. You could do it in either place, but not doing it twice, because that's not necessary. Forgot that I was already doing that. Okay, so it's already being done in update labels. So this code here remains the same. 1, 2, 3. After 3 rounds, the PC wins. Computer score 2 to 1. And at that point, you could like disable your buttons or make a reset button. All right, so let's extract this. So let's extract a method. We're going to call the method determine game winner. This game winner is right here. I'll put it beneath my update labels. So you declared it and call it determine game winner on each button click. So it really simplifies the code that goes in the event handlers, because most of the logic is now being done in our methods. Right? If I think of this method, it accepts nothing and returns an int. This takes in 2 pieces of information and returns an int. This takes in 1 piece of information and returns nothing. This takes in nothing and returns nothing. Computer 1, computer 1 again, player 1. Oh, there's a bug. Our rounds are only increasing on the button clicks. There's a bug. Num rounds is only increasing there. Let me see any place. I'm going to do a search. So num rounds is going up on rock. I got to also increase number of rounds on each one. Number of rounds on rock, number of rounds on paper. There it goes. Now after 3 rounds, the player wins. 1, 2, 3. After 3 rounds, it's a tie. 1, 2, 3. After 3 rounds, computer wins. All right, folks. This might have been a little bit much as far as, generating this many methods might not have been necessary. I might have been able to get by having a little bit of repetitive code. Shoot, if I wanted to make a method to increase the number of rounds, I could have done that, right? Because I've got repetitive code here. But it does get the point across that anytime you see repetitive code in your source code, you should consider extracting that into a method. And that really makes the code that you write in your event handlers a lot cleaner. And then when it comes time to troubleshooting your code, you're just troubleshooting each individual method. All right. So that's my code demonstration. Let me go ahead and stop the recording here. I'll take some questions if you got some.